Welcome to The State of Us.
Beyond mainstream cable news and party lines, with a millennial and a boomer, The State of Us pushes past the noise and uncovers all the issues that matter.
Here's your host, Justin T. Weller.
The United States spent $3.65 trillion on healthcare in 2018. That amount is larger than the GDPs of such countries as Brazil, the United Kingdom, Mexico, Spain, and Canada. The bulk of this spending focuses on treating ailments rather than preventing them in the first place. Most people suffer from ailments later in life, but before age 50, individuals are affected at far lower rates. What if we could stop people from physically aging past 50? What about 30 or even 10? How would that change things? It sounds far-fetched and maybe even crazy, but we are closer than we've ever been, and the science is real. Immortality Inc. is a recent book that examines these questions and more. Pew Research Center tells us that reducing healthcare costs ranks among the top tier of public priorities, and death is a universal reality that we all face, at least for now. Today, we get to speak with the author of Immortality Inc. Chip Walther is a National Geographic explorer, science journalist, filmmaker, and former CNN bureau chief. His writing has appeared in The Economist, The Wall Street Journal, Scientific American, and National Geographic. William Shatner described Immortality Inc. by saying, "What a cast, what a story, what a book." Chip, thanks for joining us.
Pleasure to be here. Thank you.
And of course, we couldn't begin this critical conversation without
TrueChat senior historian and an educator of more than 30 years. Here is your friendly redneck liberal, Lance Jackson.
Chip, how you doing? I'm very excited to talk about your book. I thoroughly enjoyed reading it, and we might as well just go ahead and get right into it.
Lance and I both enjoyed it quite a bit, and we're hoping to, we're planning to cover this topic some more in the future, because I think what we'll find today probably is that our listeners get a taste of this, but they're going to have to, at the very least, buy the book and hopefully keep listening to get the full gist. And in the book, Chip, you devote a chapter to the drive to survive. It seems that one thing nearly every person has in common is a built-in desire to stay alive. When we talk about immortality, most people immediately assume that it's a pipe dream, something that there's no way we're ever going to accomplish. Yet the book seems to suggest that it might be wise for us to spend more time and money on preventing aging rather than treating the ailments of old age. Why is that the case?
Well, the whole idea here is to arrest aging. The main reason most of us die is because we get old. And it seems kind of obvious, but when you think about it, that's when people start getting cancer. That's when people start getting diabetes, heart problems. And basically that's because your body is very slowly on a cellular level, on a molecular level, beginning to break down. And so the whole idea with the kind of, work that these scientists that are in the book are attempting to do is undercut the very, the ailments that we get. Not the ailments, actually. They're trying to undercut what causes aging in the first place. So if you eliminate aging, you eliminate pretty much most of the big diseases. Cancer starts to go away because the vast majority of people die of cancer when they're after 50. And the same thing with diabetes and heart disease, which is the biggest killer. So the whole effort here is to undercut this or find ways to slow the aging process while other process or other work that scientists are doing can actually overcome and figure out, why do we age in the first place? I mean, really, if you think about it, what is it about everything on the planet that causes us to age and die?
That's what I found very interesting, when I was reading that. It's like, we talk about finding cures for all of these different problems that we face that kill us. But the bottom line is that it's not, it is the diseases, but it's the fact that as we get older, that's when these diseases hit us. Am I understanding that? That was just like one of those epiphanies, one of those, like my head just started exploding, like, wow, that makes so much sense.
Yeah, it does, but it is strange because it's so wired into us to, that we're aging, that we just sort of take it for granted and we go, well, that's the way it is. And, but the truth is, if you're 30 years old, you're not generally ill. You know, you're not
exactly.
sick, and you feel pretty good. And the reason why is because your DNA is doing a hell of a great job fixing itself on a day-to-day basis. Unfortunately, what starts to happen is that all of those abilities, those remarkable abilities on a molecular level that enable your DNA to repair all the damage that's 15,000 hits a day, you know, on each of your 100 trillion cells, you know, and a vast majority of that gets repaired, but it gets repaired better when you're younger. And as you age, those repair mechanisms start to break down themselves. And so then the repair can't take place. And, you know, eventually you kind of clatter away and diseases take you down.
Well, and that's ultimately what aging is. I mean, is just the fact that your body can't keep up with repairing itself the way it used to. And so it makes a lot of sense that if you're going to avoid the things that plague you later in life, one of the easiest answers is to not physically get to that point.
Right. You don't want to age in the first place. And that's the goal here, to arrest aging, or as Art Levinson just recently said to me, he said, interrupt aging. And if you do that, then, well, it changes absolutely everything. I mean, it capsizes everything.
Sure.
The book, you do a great job of explaining all of the challenges that science is trying to overcome. But the one thing that I thought that, again, stuck out to me and just drove the nail home was there's a challenge to the scientific mindset. And at one point you quoted some, I forget who it was, and please feel free if you remember it, but who said scientists in their heart of hearts fear what they might find, the horrifying truth that their theories, their ideas, and the comfortable concepts that they had wrapped up in their mind for so long that they might be wrong. And I'm like, yeah, because it's like, we won't run these tests because there are, we might find out that we've been wrong all this time. And so then we don't run the test. How much of an obstacle has this been?
Well, it's first of all, the scientist we're talking about he was actually inspired by the scientist Craig Venter, who's a key character in the book. And Craig Venter is the scientist who he's world famous and was probably the most famous scientist in the world because he accelerated the sequencing of the first human genome. Yeah. And so it was I'm trying to remember his mentor who had told him, he said, look, he used this phrase. He said, do the experiment, regardless of whether or not the experiment is going to make you look bad as a scientist or not, you have to make mistakes. You have to, do things that other people are afraid to do, and that's been a hallmark of Venter's work. He got into a lot of trouble whenever he was trying to accelerate the creation of the human genome. I mean, the sequencing of the human genome, because the federal government was moving much more slowly, much more, cautiously. And he said, look, we don't have to move this fast, and we're spending billions of dollars here. We can do it faster. And he came up with a different method for doing that. Yeah.
The anecdote in the book, you talked about how he went off on his own and found his own computer system or whatever and said, I don't care what everybody else is doing. We're going to go about it this way, and I'm going to get it solved in so much less time for so much less money.
Well, and you're kind of talking about leading right into the next bit of this, which is a huge part of the book that you devote time to, is the will, the means to do this, the people behind it, necessary to solve mortality. In that part of the book, you talk about several people and organizations. Venter is one of them, of course, who have the drive to make solving the problem of mortality a possibility. So who is Venter the one that people should focus on the most, or is there an organization they should be looking at? Who do you think is the most central to this effort?
It's a good question. The reason why I mean, kind of the way the book unfolded was I just had always been fascinated with the subject. And I first got fascinated with the subject because I come across a scientist who, said that just out of nowhere, when we're having lunch, he says, I'm going to freeze myself when I die. And I'm like, what? And he basically said, well, what's the downside? Everybody dies, but at least if I can freeze myself, maybe I'll come back, and there's a company there called the Alcor Life Extension Foundation. And that's kind of how I opened the book. I go to that place. I spent a lot of time there to actually figure out what the science was behind that. But ultimately what I realized was not even the people at Alcor, who are obviously people who really don't want to die. Not even these people want to be frozen first. What they really want is, can you just keep me alive and can you keep me young, or at least younger? And so can I, and then can I live a long and healthy life? And that's where, so then I started to look more deeply into this because I thought, well, is there are we at a place in human history where it is possible that science, not snake oil, not philosophy, and theology, all the other myth, is real solid science getting close to this? And so that's when I started looking around. And what I found was, first, Calico had been founded in 2013. And I got word of that. And what was interesting about Calico was it wasn't some small company with a couple $1 million, and it wasn't a foundation. What it was an organization that was funded largely by Google. Now, Google has lots of money. So, and ultimately found out that, Google and AbbVie, another pharmaceutical company, were involved, were putting $1.5 billion behind this new company. And even more interesting was that the person that they brought in to run the company, or who agreed to run the company, is Art Levinson, who happens to be the chairman of Apple, was on the board of Google previously. And before that, and in fact, at that time was the CEO and the chairman at Genentech.
And they've kept a lot of what they're doing pretty quiet.
Yeah. Well, and we can get into that. It's interesting. I mean, Art Levinson is an interesting person. It's not that he really wants to be secretive. What he hates is saying, "Hey, we're going to solve this problem. We're going to do it in 3 years," and then everyone's, well, what happened? Why didn't it happen? He wants the science to speak for itself, and he did great things at Genentech, which is the first biotechnology company. And so when everyone looked at this and they said, oh my God, Google's behind this and Art Levinson is behind this. This is serious. I thought, okay, I'm going to start to dig into this further. And then just a few months later, Craig Venter's company was co-founded by two other individuals. One, a scientist named Robert Hariri, who is probably one of the world's leading stem cell experts, and Peter Diamandis, who is best known as the founder of the X Prizes, which I think a lot of people probably have heard of. And so anyhow, whenever I saw, and ultimately they got $300 million. So I thought, these are first-rate scientists. They're not just trying to make a buck here. They're really trying to solve the problem. And they're the kind of people that can solve those kinds of problems because they have in the past.
We've been talking with Chip Walther, author of Immortality Inc., about the wisdom in spending more time on preventing aging rather than treating the symptoms of it. We also discussed some of the obstacles and the people with the will to overcome them. But the question still remains, is achieving immortality doable? And if it is, will any of us actually live to see it? To find out, keep it here on The State of Us, and we'll be right back.
We are The State of Us. Here's your host, Justin T. Weller.
Most people suffer from ailments later in life, but before age 50, individuals are affected at far lower rates. What if we could stop people from physically aging past 50? What about 30 or even 10? How would that change things? At the onset of the show, that may sound far-fetched, but now we're going to look at the real science taking place.
All right, Chip, we've already mentioned Craig Venter, and now the Human Genome Project is a large part of why this discussion about immortality is even possible. And we can't hope to cheat death without understanding our genetic code. How significant was this project's success, and just how complex is our DNA?
So yes, it's incredibly complex, and the Human Genome Project back in the 1980s, the middle of the 1980s, when the whole concept of actually trying to understand and sequence the human genome was even thought about, a lot of scientists said, "You're crazy, can't happen, not going to happen. It will take us centuries to figure this out.
Too complicated."
I think largely because people were thinking in terms of, we're just going to have some bench scientists down there, squinting really hard and trying to figure this problem out. You can't do it that way. And that was one of the big advances that, Venter had. I mean, he wasn't the only person to say, look, you need to use computer algorithms and computer technology in order to sequence and scan those billions of, ladders of DNA. But you need to be able to, to sequence it, and only machines are going to be able to do that. And that was one of the advances that Venter got into. He found a quicker, it turns out, more accurate way to actually look at all of the DNA and understand what each of those lines of code meant. But when he sat down with the federal government, he said, look, we can do this in 3 years, not another 5 or 10 years. And they said, no, we've got to take our time. We've got to do it right. And he said, well, and then that's when this other company came in, Celera, that was formed, and they put $300 million into it. And they said, we're just going to do it on our own. And he didn't do it in 3 years. He did it in 2 years. The unfortunate thing about sequencing the human genome was that we sort of at the end of that have, by the time you sequence it, it's a little bit like opening a book of Chinese script, that's 3,000 years old, and you go, wow, there it is. What does it mean? You just can't, you don't know what it is. And so truly understanding that is where we're at now.
Now we've unlocked this, what looks like something that could have lots of potential, or we know it has lots of potential, but we don't fully understand it yet, or we don't fully have it decoded yet. And that's a huge part of why this is even possible, though, right? Because if we hadn't been able to successfully sequence DNA, then all this discussion we're having now wouldn't be possible.
Right. First, you have to have the book of life, which is the sequenced human genome. And then the next thing you need to do is understand, well, what are all those lines of code telling us? And that is where we're at right now. And one of the things that Venter has pushed really hard, at Human Longevity Inc. is saying we need a massive database of individual, sequenced genomes. I mean, the first genome to be sequenced was his. So that's fine. You got one sequenced genome. That's him,
right.
But we need to understand how everybody.
One of billions.
Yes, right. And we need to understand how does the human genome, work. And then the flip side is how does each individual's genome work? Because each genome is different. It's very similar, but it's different. And that's why some people, for example, this coronavirus thing that's going on. I mean, one of the reasons that Human Longevity Inc. discovered that the H1N1 virus, for example, they discovered that 40,000 people died from that disease. It turns out that a large number of those people died because they had a particular gene that made them more vulnerable to dying from that disease. So a lot of the people that are dying from coronavirus, sometimes they're old, sometimes they have asthma or, other issues with their lungs. But a lot of times, my guess is going to be they're going to discover that they just had an unfortunate set of genes.
So part of understanding, because, people are listening, right? And we've talked some about the obstacles. We've talked some about these people, and it all sounds like, okay, this all makes sense. This is all pretty reasonable. Mm-hmm. But then we get to the whole, you can live forever, right? Mm-hmm. And part of understanding the possibility of that, I think, and how could that be within our grasp, right? As humans, how could anything like that be achievable is understanding what you talk about in the book, the law of accelerating returns. Just how quickly is humanity progressing, and why will that continue to accelerate exponentially in the near future?
Okay, right. So we need to back up a little bit with regard to the book, because another main character in the book, and in a way, I try to write the book almost like a novel. Mm-hmm. And you have primary characters in the book, and Craig Venter is one of them, Art Levinson is one of them, and another key character is Ray Kurzweil. Ray Kurzweil is the man that came up with the concept of the law of accelerating returns, or LOAR, he calls it. And basically, the idea there is that since the Big Bang, we have been very slowly organizing information of all kinds, whether it's galactic information or cellular information or human information, has been slowly accelerating and organizing itself. And we are now at a point where we're seeing the so-called knee of the curve. So if you imagine a hockey stick and you look at the bottom of the hockey stick and it's pretty flat, and then you get to the stick part of it, all of a sudden it just sweeps up and goes almost in a straight line. That's kind of where we're at now. And so it takes a long time to get the train moving, but once you get it moving, it accelerates rapidly. And that's what we're looking at. And whenever Craig Venter discovered this new system that would accelerate sequencing the human genome, he did it because of the computer science that was developed. So that is one of the reasons why it accelerated finding the sequencing of the human genome. If you get 1 million human genomes together and you have enough algorithm, you have enough computer power and you have the algorithms that can actually figure out what the hell is going on between all those things, then you can begin to solve the problem that is incredibly complex, which is, why do we age?
And I like the way you explained the way you wrote the book, because I was telling that to Justin. I'm like, man, the way he's laid this out and the anecdotes and then you get to know the characters. You said a novel and then what each one of them are doing now. But the book's divided into 4 sections. The largest section of the book is dedicated to success and the progress that's being made. Everybody's going to want to know, and I'm going to let you say it, because as you read the book, you kind of know the answer here, but people are going to want to know, how close are we to increasing human longevity, and what will it take for us to get there?
Right. Well, when I first started writing the book, I have to admit I was skeptical. I mean,
naturally.
Yeah. Right. And I am a journalist, so.
Yeah, but you writing it, I was totally skeptical when I picked it up. And like I said, as I'm reading, I'm like, okay, now we're there, right? I mean, we're almost here. And because it's just very convincing. I mean, it's a very convincing story. So, just really, where are we now?
Well, we're getting there. I tell people there's 2 different things that I say. One is that anybody that can hang in there and stay healthy for the next 20 years, I think you're going to live a very long life, unless you get hit by a bus or something. And I believe that within the next 4 years, maybe 5, we're going to start to see some really big advances. In some ways, we're already seeing them. And I see this kind of unfolding in this way. First, stem cell therapy is going to be the first way to stem cells. The use of stem cells can recharge the human body or a particular human organ, and that's being pretty rapidly found. And there's, again, one of the main characters in the book is Robert Hariri, who's really pushing this science, and so I think that's where you're going to see the first advances. So, for example, if your heart is not doing so well, if you recharge that heart with stem cells, then you can make it younger, basically.
Excuse me, I'm sorry to interrupt, but you mentioned the stem cell, and it's like, but the real thing is because some people have kind of a query, about that. Like, but he's talking about stem cells from placenta, correct?
Yes. Yeah.
So, I mean, that was his. Who's going to have, I was thinking, who's going to have the moral, problem with that? I mean, I understand the moral issue, back when President Bush was in office.
Right, with embryonic stem cells.
He's taking stem cells from things that we dispose of, right? That he can now maybe do some of this stuff with.
In fact, the reason Hariri made this discovery and wrote a patent on it, but the reason why he got into that was because he had issues with embryonic stem cells. And so when he discovered that virtually every time a baby is born, the so-called afterbirth, which is the placenta, is just tossed in the garbage. And then he discovered that they're loaded. They're just an engine for stem cells. And by the way, they're stem cells that you can get that don't create immune problems. Your body's not going to reject a placental stem cell. It's just going to go, oh, okay, you're part of me. Come on in. So they're already discovering. I mean, normally what happens with stem cell work right now is you'll take some of the stem cells from your own body and you might inject them in your knee if you have arthritis. Problem is that if you're already, 65, 70 years old, your stem cells are 65 or 70 years old, so they're fresher because they're sort of there to be reused or to be used. But if you get them from a placental stem cell, they are brand new, fresh as that baby. but you're not hurting the baby because these are just tossed away. And so, Hariri believes that he's creating medicines now that you can either inject or just take, and that they'll be, and you can recharge whatever part of the body is needed. So that's not really solving the underlying reasons why we age, but what it's doing is it's buying time. So that's why I say it's the first wave. I think the second wave is understanding the human genome. And that's where we have to get to the point where we get large database of understanding all of the human genome, which means you have to understand what people that live in Australia, or people that live in Vietnam, and people that live in the United States, all people of all different races and backgrounds and everything, in order to truly understand what makes us tick. And by doing that, then you're going to understand all the various switches that get flipped. And the work that Calico is doing, which is, I think, the final kind of wave, is they're really focused on understanding the underlying reasons why we age. What is going on? For what evolutionary reason has caused us to break down? And what they have found, and this is really fascinating, it's a big part of the book, is they found animals that don't age. So whenever Levinson realized that, he went, then it is possible to cure aging. He himself was not sure when they started the company, Calico, whether or not that was possible. But when there are these strange little animals called the naked mole rat, and they don't age. Your average, rodent lives 3 years. Naked mole rats live 35 years, and they don't die because they age. They die because of some other reason, like the proverbial getting hit by the bus. Something else gets them.
More than 10 times as long. I mean, if you think about, if you apply that same factor to humans, right? Instead of living 80 or 90 years, you're living 800 or 900 years. Exactly. And again, the thing that'll get you, it's not like you're getting older and older and older by the time you're 900. These animals pretty much act the way they did when they were 3 or 4 years old. So you're going to be healthy, and so his big question, and the big question the company was working on, is, okay, you've got regular rodents that have this DNA, and then you've got these animals that have this DNA. They're very similar. Otherwise, what's the difference between them? If we figure out what's different, then maybe we can see the analogs in humans and find them and flip those switches, and we will simply stop aging. Because there's a lot of commonality between the two, and the key is figure out the parts, highlight the areas that are different, and then how do we apply that to humans, right? Because we already have the technology, and for people that don't know, right, we already have the technology to alter our own DNA. Yeah. So that's not the obstacle. The obstacle is figuring out what has to be altered. Exactly. Because altering the wrong thing is incredibly dangerous. Yes. You do not want to change. You go in with CRISPR, technology that enables you to snip DNA and change things, because once that's in there, then it's in there for the rest of your life and anybody else. It's not a reversible snip. No. So, and that goes back to why it's so important to understand the human genome itself. You can't run that analysis, on a human scale until you understand what all the genes mean in the first place. I mean, again, right now we're looking at them and there's a lot of blind spots in there. So when you're doing a comparison, or you want to find those analogs, you better really know what you're doing. Chip ends his book by discussing the myth of Icarus and how his last journey to the island of the namesake, where people live healthy, long lives, led him to contemplate, when forever comes, will we be able to survive it? It seems it is no longer if we will achieve immortality, but rather what happens when we do. Chip mentioned that, it might just be 20 years. If we can hang in there, we might start to see some real headway being made in this. I think it's possible in 20 years we'll have solved the problem. I think that we can begin to see real advances in 4. In the next segment of the show, Lance and I are going to break down what we've heard so far, but we're also going to discuss the question that I asked just a moment ago. It's not if we'll achieve immortality, but then what are we going to do once we have immortality? Chip, thank you very much for taking time to speak with Lance and me. My pleasure. Thank you very much. Chip Walther is the author of Immortality Inc., which you can purchase by visiting thestateofus.org or anywhere books are found. When forever comes, will we be able to survive? To find out, keep it here on The State of Us, and we'll be right back.
We are The State of Us. Here's your host, Justin T. Weller.
When forever comes, will we be able to survive? Lance and I had the opportunity earlier in today's show to talk with Chip Walther, who's a National Geographic explorer, and he's the author of the recent book, Immortality Inc. And we got to kind of walk through this whole, you talk about people living forever. And I think a lot of us, myself and Lance included, especially when we first heard about this book, are like, yeah, maybe, but probably not. And then you read what I guess there's, he described it, Lance, as a novel.
He really did set it up as characters in a novel and referred to, Mr. Ventnor and Mr. Levinson and, just went right through, and then you picked them up in the middle of the book, and then you picked them up in the success part of the book. And so you really could kind of just get to follow them along through this story. But that's not what made it believable. It's the science. I mean, These are some of the smartest people that you've never heard of. I mean, unless you're in the scientific field. I mean, I feel like you and I are pretty well read, and I hadn't heard of these gentlemen at all. And they're very much, they've won all kinds of honors and medals and Nobel Prizes and presidential awards but each in their field. And this project brought them all together to work. And it was just like, made a believer out of me. It really did. When I finished the book, when I got to the end of it, I'm like, this is logical.
Well, I think it's a big credit to Chip, right? Because it does read like you're reading a story, right? You would immediately think, when you think a novel, that it's fictional. But then it's kind of, and I think you said this at one point when you and I were talking about it, it's like you get partway through and you just kind of realize it's like, no, but this all really is happening or happened. And I think
it's an easy read.
Yes.
I mean, it just, you don't want to put it down. And I mean, we love to read, but this was something that I think, if you were born,
right,
you want to read this because you're going to die. And this talks about how you might not.
Right. Yeah. See, maybe you're going to die. Depends on how successful they are,
and how old you are right now.
Yeah. I mean, I read
on top of how well you take care of yourself. Mm-hmm. I mean, that's the other thing I'm thinking. Oh crap, man. If I'd take better care of myself and eating less double cheeseburgers, I might make it long enough for them to get me something.
That's right.
But I probably screwed up. So I probably can't make it till, what do you say, the 20 years or
20 years,
25
that was
years?
That was maybe my biggest, because I was kind of curious.
And they're not talking about reversing aging.
No.
That's the one thing people have to understand.
Well, not yet.
Yes. Right. True. That is true. Yet. All right.
I mean, you get step one done.
I guess I could always go into the cryogenic lab in Arizona.
Yeah. Just wait it out.
Yeah. Which is, that's an interesting idea when you think about it, right? Because when you test, you always have, group A and group B. Well, we know what happens to group B, right? They're going to die.
Right.
Okay. So everybody says, well, cryogenics are going to freeze you. That's stupid. No, that's never going to do any good. Okay. You're not any worse off in that group.
You're still dead.
Right. You're going to be dead just like you would be if you didn't do it.
Right. But
I thought was a logical argument.
Yeah. Well, there is you think about if your body goes into the ground, right, and it decays, or you're cremated or whatever, there's basically no chance.
They're not bringing you back, right?
Right.
They're not bringing you back.
Probably not.
Unless they got your DNA strand somewhere in a petri dish, and right? I don't know.
If your body and your cells are preserved, shortly after death, then it sounds like some of this gets into that possibility. But really, that was the thing that I was surprised, not because it seemed short, but I guess just because I was surprised that he felt as confident as he did that within 20 years, we're going to see something major in this area.
Okay, but your big problem with this whole thing, okay, at least it was before you went up and talked to him.
I wouldn't say it's a problem.
Until we went up and talked to him here.
My big question
was you're worried about how many people, about the reproduction process. Your take, and please correct me if I'm wrong, is you're worried about overpopulation, because if people say they stop at the age of 35 and they want to be 35 all the time or 25, then they're going to continue to reproduce all those years. And then everybody else stops at their maximum age, 25, 30, whatever they like the most or whatever. And I came back and I said, no, but part of the whole cultural idea that we have as humans is we reproduce to leave a legacy, or to keep our legacy alive, or to keep the name going. You wouldn't have to do that.
I don't want to say problem. It's just my concern with us not giving it enough thought before we get to, we have these people living a long time. And he ended the book with saying, and this is what we ended the last segment on, when forever comes, will we be able to survive it? And that's a big question. I mean, the immediate thing is, of course, the overpopulation that comes to mind, the food issues, right? I mean, there's a whole host of things that comes with, if there's, 2 or 3 times as many people on Earth, what does that do? And that's a discussion in of itself.
But you don't have to retire and have a bucket list, because you're going to live forever. So you can go see whatever it is you want to see whenever you want to see it.
Right.
You can, for the next 200 years, take your 2-week vacation and go to the things on your bucket list each year. And you're 35 the whole time.
Right.
I guess I'm picking 35, probably 25 would be better, but
Lance and I think both thoroughly enjoyed the book, and there's a lot of big questions left to answer that we just don't have time to. So we're hoping to fit in another episode or 2 on this topic in the future. But you got anything else, Lance, that you're a believer now, right? I mean,
no, I really am.
This
is one of the most interesting topics that I've read about in the last 10 years.
Wow. Yeah. I think for Lance and I both,
they sold me, and it's hard to make me a believer of something. I am a skeptic one of the highest levels.
You have never said a truer statement. We encourage people, right? thestateofus.org. You can buy a copy of the book if you want. And if you're so inclined to go to the State of Us, it's a link that'll take you to Amazon, but we get a little piece of that. So it's real nice if you all decide you want to pick up a copy to go through the State of Us, so that we get our piece of turning you on to the book and making you think about this. But hopefully we've got more episodes to come. And Lance, these conversations, right? This is what it's all about.
It is.
What is our mission here?
Well, the mission statement here at True Chat is to educate people by providing honest, open, and respectful conversations, which I think we've done. And again, it doesn't do us a lot of good if you don't go out and tell people to listen to us.
That's right.
So however it is that you listen to us, let others know. I know that I had 2 new listeners from school this week.
Oh, yeah?
They found us on their favorite, which was Spotify, which I told them was my favorite. But we're also found on Stitcher, Apple Podcasts, and anywhere else that you find fine podcasts like this one.
For the State of Us on True Chat in Cleveland, Ohio, I'm Justin T. Weller.
I'm Lance Jackson.
Special thanks to Chip Walther for joining us, and our producer Bradley Butch for making the episode possible. We'll see you next time. Be the change. Be sure to check out our website, thestateofus.org, for books, articles, and all the ways to tune in. thestateofus.org.